share the attendance link. So now we move to the next topic, okay, which is on the guideline for slope design. Okay.
Let's prove the link for Makaj 1043. It's not act. The link of
Second link don't work.
Don't
already
work.
at 01043. Don't work.
Yes,
Okay. Let me check. Okay. Thank you. Let me check first. Okay, can you try again?
Yes, it's okay now.
Okay. So now we discuss on the guideline for slope design. Okay. So actually this guideline I obtained from Public Work Department of Malaysia, okay, under the slope engineering branch. In Malaysia we call as Cawangan Kejuruteraan Cerun, okay, or CKC, the short form CKC, okay. So this guideline, okay, actually has been used or follow some of the guideline from the Hong Kong slope branch, okay, and also from the British or from the Britain or the UK guideline design, okay. So in Malaysia, okay, Malaysia, in 2004, okay, Malaysian government, okay, has directed Public Work Department of Malaysia to establish a new branch called as the Slope Engineering Branch. Okay. This branch has since been involved in mitigation, research and development, risk management, safety and planning on slope, especially in Malaysia. Okay. So the guidelines was prepared by the Slope Engineering Branch, Public Work Department of Malaysia. It is to be used as a supplement to other geotechnical manual, such as geotechnical manual for slopes published by Geo Hong Kong, British Standard, and other accepted standard practice. Okay, most of the investigation carried out those far revealed that cause of landslide were due to physical, geological, and human elements. Okay, so the physical is more related to the physical of the slope. Okay, so for example, due to the geometry, okay, due to the water or rainfall infiltration. Okay, so while on the geological, due to the what is the parent rock, okay, and due to the weathering process, okay, while for the human elements, most probably due to the construction or development, okay, cutting, okay, whatever that related to human activities. Okay. So based on landslide forensic statistical data, for large scale failure from year 2004 to 2007, okay, it was found that about 50%, 57% of landslide were due to human factor, whereas 29% were attributed to physical factor and 14% caused by various geological factor, okay, which is listed in table 1. Okay. 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 It was discovered that the most of the landslide occur at man-made slope. Okay. So I guess most of the listed area here, okay, is the area that has a development. Okay. For example, at Taman Harmonis, it is a residency area. Okay. And then Kampung Pasir, Hulu Selangor, which is Hulu Kelang, which is Hulu Kelang. There are a lot of residence area. Okay, so Kampung Pasir is a part of a part of the development area. Okay, so while in Sabah, okay, this is located at what we call as at the Federal Road. Okay. Okay. However, this is due to the physical factor. Okay, most probably due to the rain, okay, or whatever related to physical factor. Okay. So while for the Wangsa Maju, this is a very dense area. Okay. So due to the human factor. Okay. And for this, it is located at federal government quarters, okay, due to geological factor, most probably due to the weathering process. Okay. And then we have another one at the Federal Road, okay, which is located at Butterworth to Ipoh. Okay. So human factor, okay, functional damage on Plus Expressway, okay. So only 7 has been listed, okay, because it relate to a very large scale failure. Okay. So the main objective for formulating this guideline are stipulate guiding principle to JKR. JKR is Public Work Department. Okay, in Malay we call as Jabatan Kerja Raya, and other engineering involved in slope design. Okay. So as a guideline, okay. So minimize risk in slope failure disaster. Okay. Increase stability of the slope, create awareness of the risk involved in slope design to further enhance existing geotechnical requirement in slope design. Okay. So this is the idea of creating this design guideline, okay, which is covered as a guideline, okay, to minimize the risk, okay, and also to enhance the geotechnical knowledge, okay, in slope design. Okay. So the methodology used in creating this guideline, okay, study of landslide forensic statistic, adopted fact safety from international standards such as Geo Hong Kong and British standard, study on existing typical cross-section of slope features, study of site investigation requirement, drainage system, survey data, and etc. Review of historical data records such as design report, as-built drawing, survey data, site investigation data, and etc. Okay. So what is the responsibility for the design from the designer? Okay, designer should search and study or report on feasibility study, development plan, investigation related to the work so as to enable full understanding of factor which may affect the work. Okay, so so the designer should have a preliminary study, okay, about the area. Okay, notwithstanding requirements stipulated herein, the designer should certify the aspect of aesthetic, function and safety requirement, stability and effectiveness completed to the intent of the works. Okay, so this is the list for the designer. So all designers should follow this requirement. Okay. So survey data, the designer should carry out detailed topographical, hydrological and land survey of the proposed site and area that may be affected by the works, which may be necessary to supplement an available survey information for the satisfactory execution of design and construction of the work. Okay. So further investigation should be carried out by the designer. Okay. Although on the first stage, during the tender stage, okay, so there will be some preliminary site investigation work will be prepared. Okay. However, in terms to have a good analysis, further detailed study should be carried out. Okay? So design should be responsible for the accuracy of survey data that is used in design work. Okay. So normally when I've been asked to design, okay, or to check for the stability of the slope, so I need to have the topographical data, okay, and also from the site investigation work. Okay. So basically for the hydrologic, okay, it's not necessary for me, okay, unless if I want to carry out for a very thorough study. Okay. For example, if the study is related to the slope failure, okay, so we need to get the hydrologic data, okay, in order to investigate what is the main cause of the failure. Okay. So site investigation, okay, in general, the designer should undertake his own additional site investigation or SI and material survey for the purpose of evaluation of the engineering design and construction of the work. Okay. So the preliminary site investigation result, if provided by the client, are to be used as a preliminary or guide, general guide only. Okay. So additional SI should be carried out. Okay. If not, unless there is no allocation, okay, or any budget allocated for to carry out for the SI, so the designer can use, okay, the preliminary SI result. Okay, the client is not obliged to guarantee the completeness and accuracy of the preliminary soil investigation result. Okay, so in that case, okay, the client, for me, for my opinion, the client should provide an additional cost if uh, if it has been requested by the designer. Okay, so we cannot make any assumption easily unless, okay, if we have a budget to carry out for further site investigation work. All site investigation work should comply with BS9, BS5930, BS1377, Geo Hong Kong Guide to Site Investigation and JKR specification for SI work. Design data. All detail of the geological design should be based on the data interpreted from the preliminary SI report and other additional site investigation report carried out by designer. Okay. All detailed design should be accompanied by a summary of the result of field exploration and laboratory investigation. Okay. So that is the rule, or that is the role of designer under the site investigation. Okay. So for the site investigation, design soil parameter, okay, design soil parameter should be shown in figure or photo together with selected value that include but not limited to the following. Okay. So this is the compulsory things that need to be obtained from the SI, okay, for the design purpose. Okay, we need weight, liquid limit, plastic limit, okay, chemical properties, consolidation, CHC permeability, okay, groundwater level, shear strength parameter, include effective and total stress. Okay, so this is the main, the compulsory parameter, okay, that normally being used in design process. Okay, so engineering geological mapping and investigation. Okay, so for geological mapping, okay, so we have two types of geological mapping. Okay, the first is based on the geological condition of the area. Okay, so then we may get this map from the Jabatan Mineralogy and Geoscience, JMG. Okay, that is one of the department that in charge for the geological map in Malaysia. Okay. The second one is the geological map. When we do a mapping, okay, on the rock surface, okay, which is on the deep deep direction, orientation, discontinuity. Okay, so we may use that. We may draw or we may determine all the important parameter on the rock surface. Okay, so you can just read this paragraph later on. Okay. Okay, for the rock and adjacent salt. Okay, discontinuity data collection and rock. Okay, so this is the explanation on the discontinuity. Okay, while for the first one is based on the map for the whole area. Okay. Okay. So independent check of slope stabilization. Okay. So for example, the designer has carried out for the analysis. Okay. Then the authority will ask this design should be checked by IGC, Independent Geotechnical Checker. Okay, so the IGC should have working experience in the technical work at least. Okay, if he or she has a master or PhD, so at least 5 years, or if or she has master at least 10 years, and 12 years if he or she has a bachelor degree. Okay. So I have experience appointed as an independent geotechnical design, geotechnical checker. Okay. So I need to check for the design submitted by the designer, then provide a comment on the design. Okay. So that is the advantage. Okay. If we have an experience in geotechnical work, okay, and then there will be the authority will appoint us as a independent checker, independent geotechnical checker. No need for us to have PE, professional engineer, practicing. Okay. For my case, I only have a PE without practicing. Okay. So I can be appointed as an independent geotechnical checker. Okay. So fill material for the earthwork. Okay. Material used in the construction of field and slope embankment should, if it's suitable, as far as possible, be those excavated from adjacent cut. Okay, so we need to follow from another guideline. Okay, where we need to identify either the material is suitable or unsuitable material. Okay, so there are some guidelines. Okay, so we need to carry out for several testing. Okay. Okay. So rock excavated from the cuts may be used as a material for fill if they are crushed to acceptable grading envelope within maximum size of individual pieces, not larger than 100 mm. Okay. So this is the if want to use the rock material, so need to be grind. Okay. So then drying out the fill material during hauling and handling from cut to position of piece should shall have to be allowed for. Okay. So they are allowed to carry out for the drying. So means that they move to another part and then let it dry and then reuse it again. Settlement analysis should be carried out for the field slope and embankment depending on the subsoil condition encountered. Design of field of slope or field slope or embankment should be based on 90% settlement during construction. Okay. If ground improvement method are used, the settlement analysis will consider the type of the ground improvement method used. Okay. So settlement analysis should be carried out. Then we need to follow based on the 90% of settlement during construction. Okay. So then need to refer to table 2. Okay. So the table 2 this year. Okay. So at least the settlement, allowable settlement should less than 100 millimeter. Okay. Within 10 meter from the bridge approach. Okay, so that is the uh, allowable movement. Okay, on the road itself, okay, for embankment, okay, should be less than 250. Okay, so we need to calculate for the 7 years. Okay, so it should be less than the amount listed here. Okay, so that is for the settlement analysis. Okay, then should be carried out for the slope stability analysis. Okay, so this is what we have discussed in detail. Okay, for the slope stability. Okay, okay. So this is what I guess this is what we just discussed on the previous class as well. Okay. So for the rock slope, okay. So for the rock slope, this is the type of stabilization, okay, that could be used. Okay. Then later on, I will show the diagram. What is the rock anchor, rock dowel, rock bolting, buttress wall, counterport. Okay. Okay. For the rock slope. Okay. Okay, this is for the cut slope. Okay, I just go for the important thing. Okay, so minimum of 2 meter berm width. Okay, so make sure that the width of the berm is 2 meter. Okay, and for every 6 meter, okay, should have one berm. Okay, so or the height of berm is 6 meter. Okay, the maximum height. Okay, so then if, for example, if we have 12 meter height of slope, so we need to have 2 berms. Okay? However, due to the maintenance reason and due to minimize risk to for user, the maximum number of berm for cut slope should be restricted to only 6 berm. So 6 times 6, 36 meter okay, for cut slope. Okay, so 36 meter height of the slope. Okay. So if the design show that more than 6 berm are required, other solutions such as tunnel, rock shed, bridge should be considered. Okay, so in that case, need to use another solution. Okay. So that is for the cut slope. Okay, I guess similar with the field slope and embankment. Okay, so we need to make sure that 2 meter berm, okay, for every 6 meter high. Okay. And then this is the method of stabilization. Okay, geogrid, geotextile, reinforced concrete, reinforced field structure, replacing with field and elevated structure. So the same condition here, maximum to 6. Okay, if more than 6, so other solution bridge via duct and etc. shall be considered. Okay. So drain, surface drain, there are 2 types of drain, surface drain and another one is subsurface drain. Okay, surface drain is what we can look or we can observe, while subsurface drain is called as a horizontal drain. Okay. So structure 8006. The type of the foundation for the reinforced structure should be designed based on the subsoil profile and geotechnical property of the footing, subsoil at each location. Okay. Okay, so this is table 2 as I told you before. Okay, so they have listed all the important design component here. Okay, for example, for unreinforced slope, okay, what will be the minimum factor safety more than 2. Okay, so if reinforced or treated soil, okay, not on soft ground, so this is the value. Okay, so it also include the maximum permissible movement or allowable movement. They have vertical, okay, vertical going down, lateral going on the left. Differential, for example, is the difference between one point to another point. Okay, so if we have two this is just example point. Okay, so we need to determine what will be the settlement here and what will be the settlement here. Okay, so then get the differential. Okay, so in this case, we may get what will be the degree. So we can get it from 1 to 150, for example. Okay, so that's the ratio. So we need to check all these design component. Okay, rigid retaining structure. So this is the element that should be considered. Okay, so and up to embankment on soft ground. So we can use this guideline for any technical structure. Okay, so this is a buffer zone. Okay, development in hilly area. Okay, for example, this is the height of the slope. So make sure that we have a buffer zone more than h value or height of the slope. Okay, the minimum is equal to h. Okay, means that if this 10 meter, so the distance should be 10 meter as well. Okay. Okay, okay. So we have here rubber wall, okay, gabion wall. Yeah, I already shared the typical cross section. So if you want to get more or you want to get more information, so then you can try to search in detail. Okay. So at least you know what is the diagram. Okay. So this is reinforced concrete wall or retaining structure. Then we have a sheet pile. Okay, reinforced earth wall, creep wall, contiguous bore pile. Okay. So actually for any retaining structure from the previous one, the maximum height is 8 meter. Okay. So if we want to more than 6 meter, if you want to more than 6 meter, so we can use this bore pile. This bore pile. Where is the bore pile? Where is the bore pile? This one. Okay, so this is more than 6 meter height. Okay, so this is a type of retaining structure. Then we move to slope stabilization. We have ground anchor, soil nailing, and tie back, soil nailing and grid beam, graniting. Okay, this is under surface protection. It only cover for the surface. From the previous is a retaining structure. Surface protection. Okay, surface protection gabion mattress, geosynthetic. Okay. Okay, well, this is for more on good methods, which is hydroseeding and close turfing. Okay, so this is for the rock area, the rock for fencing, okay. Rock boat, okay. Then we have rock netting. Okay, this is a sabo dam. Okay, this is another method. How to know which, okay, so it depends on our analysis. Okay, so for example, if we did the analysis and we fail, okay, so then we need to try and we need to try to improve by using any type of improvement method. Okay, and also it may related to budget costing. Okay. So if we put a lot of money, so definitely we can have a very good retaining or any good improvement structure. So for my case, I have experience design for retaining wall, soil nailing. Okay, so it depend. Okay? Depend on the case. Okay, this is rock shed. Okay, to prevent from any rock fall on from the top. Okay, that's all for today class. We will have a next class discuss on embankment, construction on embankment. So I guess we only have 2 more weeks before the semester break. Okay. So next will be embankment and last one will be on the monitoring. Okay. So most probably for embankment, the discussion will be 1 hour. Okay. If you ask me to combine, so there will be no class for the next 2 following weeks. Okay. Okay. So that's all for today. Okay. So we will meet next week. Okay.